Let's review our absolute value unit. The following is a graph of the two sides of an absolute value equation. What is the solution to the equation? Here we've got the left side and the right side graphed separately, just like we do in Desmos. So what we're looking for are the intersections. So our solution at the is the x value at the intersection of these two lines. So I'm going to look for those intersection points. I have one here at -5, 3, and another over here at 1, 3. So my solutions are the x values, 5 and 1, or excuse me, -5 and 1. So I'm looking at -5 or 1, answer choice C. Number 2, which inequality describes the solution set graphed below? So when we have our one variable inequalities, we are going to put the left side into the first box in Desmos, the right side into the second box, and then we're going to put the whole thing in the third box. So for this, we have to start out with our answer choices, and we are looking for closed dots, so less than or equal to or greater than or equal to, because here we have our closed dots on our number line. We're also looking for intersections where x is -3 and where x is 4. And then we're looking to have it shaded in between these two. So we're going to plug our answer choices in Desmos and see what works. So in Desmos, I'm going to put the left side in the first box, the right side in the second, the whole thing in the third. And that gives me my graph. So this is answer choice A. And if I look and click on those intersections, I have one at -3 and one at 4. So the intersections are right, but it's not shaded in between. It's shaded on the outsides. So that doesn't match our number line up here. So I'm going to move on to my next one. We mark out answer choice A. And if we notice for B, the only thing that changes between A and B is the symbol right here. It changes from greater than to less than. So my left side is still the same as it was, as is my right. But the whole thing, I need to change the symbol to a less than or equal to. So in the third box, I'm going to make that change. And we see now it's shaded in between. And if we click on those intersections, we get an intersection where x is -3 and where x is 4, which matches our number line. It's shaded in the middle, just like on our number line. And our answer choice does have the line under the symbol, which is what we're looking for to match the closed dots. So we pick B for our answer. Number 3 says how many values of x will satisfy the equation -5 times the absolute value of -6 plus 4x equals 6. So here we don't care what the intersection is, we just want to see how many intersections there are. So it says how many values. We're not asked to find the actual value, just how many. So in Desmos, I put the left side in the first box, the right side in the second box. So I'll go to Desmos and I enter the left and right side in the first and second box. It graphs it for me over here. And if I look, I see I've got a line up here. That's my y equals 6. And then down here is our absolute value in red. And they don't intersect at all. So that means with no intersections, there's no solutions. And I pick 0 for my answer. Okay, so what is the solution set for the given equation? 2 times the absolute value of m minus 3 equals 24. So again, in Desmos, I put the left side in the first box, the right side in my second box. And don't forget, Desmos can't graph m. It doesn't know what it is. So we have to put x instead. So in Desmos, the first box will be 2 times the absolute value of x minus 3. And I'll put y equals 24 in the second box. So when I look here, I don't see an intersection yet. So I need to zoom out. I'm going to click the zoom out button. And when I zoom out, I do see that I have two intersections here. So I can click on them. And I get the numbers for x as -9 and 15. So -9 and 15, that's my answer. I circle B. Number 5, which inequality describes the solution set graph below? This is very similar to that other problem we saw a few slides ago. But here, with our inequality line, we're looking for the closed circle, shading on the outside, and intersections at 2 and 4. So in Desmos, I'm going to try my answer choices with the left side in the first box, the right side in the second box, the whole thing in the third box, since we do that for every inequality. I'm looking for closed dots, and if I look at all my answer choices, we have the line underneath, so that would be closed dots for all. That doesn't help me narrow it down any. I want intersections where x is 2 and where x is 4. And then I want it shaded in 2 places. So it's not shaded in between, it's shaded on the 2 outer edges. So I'm going to bring up Desmos, and I'm going to plug in my first answer choice. The absolute value of x plus 2 in the first box, and y equals 4 in the second box, the whole thing in the third box. And I can look at this one here, and when I click on my intersection points, I see that my x values at these intersections are -6 and 2. Well, 2 matches, but -6 doesn't. So that's not going to work. So I'm going to mark out answer choice A. Now, if I look at B, the only thing that changes is the direction of my symbol. So the intersections of these first two, the absolute value of x plus 2 and 4, are going to be at these same 2 numbers. So I'm going to skip over that one. Now I'm going to try C. I want the absolute value of x minus 3 in the first box, and 1 in the second box, the whole thing in the third box. I'm going to click on my points for my intersections, and I get 2 and 4. That matches 2 and 4. I want it shaded on the outside 2 places, so over here and over here. That matches my number line. And again, if you actually look at the x-axis, where the x-axis is shaded should match the number line here, and it does. So we are going to circle C for our answer. Number 6, write your answer in the box. Use the slash for a fraction or dot for a decimal if needed. The absolute value equation below has 2 solutions. If one of the solutions is x equals 7, what is the other solution? We're going to go to Desmos, left side in the first box, right side in the second box. It's not an inequality, so I don't need anything in the third box. We know that 7 is one of the answers, so I'm going to look for the other intersection. We're going to go to Desmos, the left side in the first box, right side in the second. Now, I can see this up here. It's really close to the top corner, so I can take this and drag it down just a little bit. Now I can see it a little better. We're going to click on those points, and we get 3 and 7 as our x values. Well, we already know about 7. 3 is the one we don't have, so 3 is the answer we'll put. All right. For number 7, which graph best represents the following equation? This one, we just have to match the picture. So we're going to go to Desmos and match the graph. I'm going to bring up Desmos, and I'm going to put the whole thing in the first box. And I get a red graph over here. And what I do, if there's any doubt of which one it matches up to, I'll pick a few points. And here you see it's on the x-axis at 5, and that's where the vertex is. So I can look over here for that. So the only one where the vertex is on the x-axis, where x is 5, is right there for answer choice A. So that makes our answer pretty obvious. If you had a couple of them that were close, I would check 2 points. Perhaps the vertex here and then the point here at 0, 5 would be another one we could check to see if they match up to the graph. But this one was pretty clear. All right, last example. Number 8, what are the apparent zeros of the graph? Remember, a 0 is an x-intercept. So we are looking at the x values at the x-intercepts. And when I look at the graph, we have 1 on the left at -7 and 1 on the right where x is 5. So -7 and 5 are my zeros. My x-intercepts, -7, 0 and 5, 0. I only want the x values, -7 and 5, so I circle answer choice C. For this one, we're also going to find our domain and our range. For our domain, set builder notation. Remember, set builder means we're using our squiggly brackets and equals, or possibly our inequality symbols. So for this one, domain, if you remember that the absolute value function has the domain of all real numbers all the time, it makes that really easy. Even if you forget, though, as you look to the left and to the right, as we go to the left, it keeps going. As we go to the right, it keeps going. So our x values will continue indefinitely. So for our set builder notation, x is included in the set of all real numbers, or our domain is all real numbers. For interval notation, what we want to do is have the lowest value first and then the highest value. So it can go all the way to -infinity, all the way to +infinity. So our interval notation here, our lowest point would be -infinity, highest would be +infinity. So we're going to write that, and we're going to use open parentheses and close parentheses around it, because we don't use the squared off brackets for any infinity. We only use those for if it includes an actual number. Now for our range, the first thing I have to do with my range is look for the vertex. And we have a vertex here at -1, -6. And what I'm looking at is my y value here at -6. And at -6, y goes up. So if I hold my cursor here, and we can pretend it's our pencil, we're tracing this line, and I go down. I can't go below -6. I can only go above -6. So that means that y is going to be greater than or equal to -6. Now, for my interval notation, I put the lowest value first, and the smallest y gets is -6. So -6 has to come first, and we're going to use squared off brackets because it can equal -6. So if the number is included, we use the squared brackets. Now, the highest it gets, well, it keeps going forever, so the highest it gets is +infinity. So we can fill in our interval notation of -6, infinity.